welcome to the trigonometry course. So, what is trigonometry? So, from ancient Greek, trigonon means triangle and metron mean measure. So, trigonometry is generally a branch of mathematics concerned with the relationship between angles and side lengths of triangles. What are angles? So angles is the space from when two rays or lines meet at a single point called a vertex. And let's say so we have two lines. So like this. This is called a ray or a line. So we have two lines and this is called a vertex. Here. And the angle here is the space that is between these two rays. Let's call it theta. Okay. So how do we measure angles? So we measure angles by degrees. Say that we have a unit circle. Okay. Wait, let me draw that bigger. And we know that circle rotation is 360 degrees, and half of the rotation is 180 degrees. So here is 180 degrees, and half of 180 is 90 degrees, and this is 270 degrees. Okay, so you can call this as 0 or 360, the full rotation. And we want to split this into thirds. So we have 30 degrees, 60 degrees, 120 degrees, and here we have 150 degrees, and we have here which is 210 degrees. Here we have 240 degrees, and here we have 300 degrees, and then our last one, which is 330 degrees. And then we want to make it in halves, so we have 45 degrees, and we have our 135 degrees, and we have our 225 degrees, and we have our 315 degrees. Okay, so this is the special angles in trigonometry. What are terminal angles? The ray that represent the ending position of an angle after rotation from the initial side. And also, what are coterminal angles? So coterminal angles are angles in standard position with the initial side on the positive axis and then share the same terminal side. So the terminal angle is, this is our initial side, and after rotation this is called our terminal angle. And for coterminal angle, this is our initial side, and this is our terminal, right? But let's say this is we make an angle of 45 degrees, and let's say we want to from 0 degrees and rotate the initial site back to 45 degrees, 360. This is counterclockwise, okay? So we always rotate by counterclockwise. Clockwise. But you can do clockwise, but it will be negative. So this will become 45 degrees plus 360 degrees, which is 405 degrees. Okay, and that is our coterminal. This is our coterminal. So this is 45 and 405 degrees. And if we want to, from the clockwise direction, so from here to here, we have to have 45 minus 360 degrees, which is 315, right? 315 degrees. So negative 315 degrees. Sorry about that. Negative 315 degrees. And this is a coterminal angle also. Terminal angle. And so we can conclude that to have a coterminal angle, or to find a coterminal angle, we just need to add by 360 degrees or minus by 360 degrees. Well, that's basically it. And this is some practice questions. So what is the smallest positive angle coterminal with 400 degrees? So we just need to find the smallest positive. So we have 400 degrees minus 360 degrees, which is 40 degrees. Okay, it's at smallest positive, so it's 40 degrees. If we add by 360 degrees, it's already more than 40 degrees. So this is the coterminal, the smallest positive coterminal angle. And then find a negative angle that is coterminal with 60 degrees. So to find a coterminal angle that is negative, so it can be negative, any negative. So we have 300 negative 360, we minus by 360, and that will become negative 300 degrees. Or you want to minus by another 360, it's okay. So we have negative 660. Okay, these and so on, these are coterminal, negative coterminal to 60 degrees. Are negative 100 degrees and 260 degrees coterminal? So we can pick one of them. We pick 260 degrees. So we have 260 degrees. Look at here, we have a negative, so we must minus 360 degrees to check. So 260 minus 360 is negative 100 degrees. And we can see that this is coterminal, okay? Because when we minus by 360, negative 100 is coterminal with 260. And if we do that to negative 100 plus 360, we will get 260 back. So these are coterminal. Yes. Give two angles, one positive and one negative, that are coterminal with 100 degrees. And we just do that by adding again 360 and minus by 360. So we will get what's this, 540 degrees, yeah, and this is negative 180 degrees. An angle measures negative 700 degrees. What is the smallest positive coterminal angle? So again, negative 700. To make it positive, we need to add by 360, and we have this should be negative 300, right? Yep, 340. Okay, and we add by another 360, we will have 20 degrees, right? Yeah, we add, and then that's our answer, the smallest positive quaternion angle. Okay, next. So, and then what is an arc length? The distance along the curved line of a circle or any curve between two points. So this is, if we have a circle, if we have a circle, you can pick this one, this one, and this one. This part is arc length, or this part can be an arc length. So the arc length formula is given by the arc length over the circumference 2 pi r is equals to the angle over 360 degrees. So find the radius of a circle if an arc length of 6 meters is subtended by a central angle of 120 degrees. So we have arc length equals to theta over 180 times pi r, right? So that means our radius must be arc length over pi times 360 over our angle theta. So we have the radius is equals to arc length 6 over pi times 360 over the angle, which is 120. So this is just 3, and we have times, this is, yeah, that's 3 and 6 meters. We would have 18, r equals to 18 over pi. Okay. Oh, sorry, my bad. It's not 120. Sorry, I haven't sleep. It's getting late. It's times by 180. So our angle is up here. What am I doing? So it's not 360, right? And it's times by 180 over theta. Okay, and our radius must be our arc length, which is 6 over pi times by 180 over 120. This cancels 20. This cancels, becomes 9. So 9 over pi. 9 over pi meters in this case. Meters. Next, a central at 300 degrees has an arc length of 15 inches. What is the radius? Again, the radius equals to arc length over pi times 180 over theta, and that implies that arc length is just 15, right, over pi times 180 over 300 degrees, and this can cancel. This will become our 60, right? 60, and this is will be 3. This can cancel out, 20. Okay, and this 20 and 180 will become 9, and then times 1 over pi, 9 over pi, and this is inches. Next, a merry-go-round has a radius of 4 meters. If a child rides on the edge and completes a turn what is the distance traveled? So this is finding the arc length. We already know it's theta over 180 times by pi r, and theta here is 225 over 180 times pi times r. What's the radius? It's just 4. This is 4. And we could cancel this. This becomes 90 to this becomes 45. Okay. Well, this and this can cancel. This becomes 9, and this becomes 45. This becomes 5, and we have here 5 meters here. 5 pi, right? 5 pi meters. All right. Radians, what is it? So radians is the measurement of angles using radius. So we have c equals to pi r, right? This is the distance of the circumference of the circle, and the same idea. So the full circumference is 2 pi, right? 2 pi. Half of it must be pi, and half of pi must be pi over 2, and this is 3 pi over 2 radians. Okay. Again, let's say we want to divide into thirds. We have pi over 6, right? And then we have pi over 3, right? And then we have pi over 2, and then we have 4 pi over 6, pi over 6, and we have 5 pi over 6, and then we have 7 pi over 6, and then 9 pi over 6, and then this is sorry, this is 8. 8 pi over 6. Yep. And then we have 9, and then we have 10 pi over 6, or 5 by 3. 5 pi by 3. And then we have here 11 pi over 6. And then again we can do it into halves. We have pi over 4. Okay, from pi over 2 times 1 over 2. And then we can have here 3 pi, or I can erase that. So we have 3 pi over 4 here. 3 pi over 4. Okay. Again, we have 4 pi over 4, which is 1 pi, and then we have 5 pi over 4 here. And then finally, we have 7 pi, right, over 4. Okay, that's our unit circle in radians. So quadrilateral angles using radians, the same concept. If I have like pi over 4, or this is 45 degrees, and let's say we want to rotate it counterclockwise, and then into this angle again, we have pi over 4 plus by 2 pi. So we have pi over 4 plus 8 pi over 4, 9 pi over 4. And also clockwise to here, pi over 4 minus 2 pi. We will have pi over 4 minus 8 pi over 4, negative 7 pi over 4. And these are coterminal more cleaner, so coterminal angles to pi over 4. And what is the smallest positive angle coterminal with 2 pi over 6? Well, 2 pi over 6, 25 pi. 25 pi over 6. We have to minus 2 pi, okay? And we have 25 pi over 6 minus 12 pi over 6. We will have 13, right? 13 pi over 6. If we minus by pi over 2 pi again, we will have 13 pi minus 12 pi over 6. We would have pi over 6. If we minus by 2 pi again, we will get a negative. So this is the smallest coterminal angle. It's pi over 6. Find a negative angle that's coterminal. So a negative angle. So we have 7 pi over 6 minus 2 pi. We have again 7 pi over 6 minus, oh, this is 4, my bad. This is 4. So 7 pi over 4 minus 2 pi. We'll have 7 pi minus 8 pi over 4. So negative pi over 4. That's it. That's the coterminal angle. We have a negative angle, right? Are 10 pi over 3 and negative 2 pi over 3 coterminals, so we just have to check one of them when we add or minus by 2 pi. Does it equals to the same thing? So let us try 10 pi over 3 minus by 2 pi. We have 10 pi minus 6 pi, right? 6 pi. And then we have 4 pi over 3. And then we have to minus by 2 pi again. Minus by 2 pi to get close to this. And we have 4 minus 4 pi minus 6 pi over 4. Over 3. We have negative 2 pi over 3. Oh, look, it's the same. So it's coterminal. So let us check with the negative 2 pi over 3. When we add by 2 pi, it doesn't become 6, and we have 4 pi over 3. Add by 2 pi again, we would have, if we 6, this one becomes 6, and 10 pi over 3. So it checks out. So these two are coterminal. Oh, yes. Arc length using radians. So we have arc length using degrees, right? So arc length using radius, we just have S equals to R theta. That's it. Okay. S, where S is the arc length. What is the arc length of a circle with a radius of 12 centimeters with central angle of 5 pi over 6 radians? Just substitute into the formula. We have S, or AL, arc length use AL, equals to 12 centimeters times by theta. 5 pi over 6 cancel, 2 will have 10 pi, right? Centimeters. And next we have find radius. So radius equals to theta over the arc length, or similarly theta over AL. So an arc length of 10 pi, and then a center angle of 4 pi over 3. So this becomes 4 pi over 3 times 1 over 10 pi. Well, cancel. We have 5, 2. And then this will become 2 over 15. Okay. Wait, let me check if this is correct. Yep. 2, 5, and we're 15. 2 over 15. Yeah, the answer is 2 over 15 meters. Okay. Meters. Okay. And conversion. So you might be asking how to convert uh, degrees to radians and radians to degrees. And degrees to radians is just by, so the degree times by pi, okay, over 180. But the radians is just backwards, so we have the radians times by radians to degrees, it's 180 over pi. That's it. This is our degree, and this is, oh sorry, yeah, this is our degree, and this is our radians. Okay. And an example for it, let's say we want to convert pi over 4 to degrees. So we use the radians to degrees. We have pi over 4 times 180 over pi. This cancels out, and you will have this one, 18 divided by 4. You'll have so we have 4 divided by 880. 4 16, 4 16. Oh wait, 45 degrees. Okay, so it's just 45 degrees. And let's say we have 210 degrees, right? 210 degrees to radians, so you'll have times pi over 180 is equals to, and cancels the zeros, and we will have, this cancels out. You can divide by them by 3, right? Yeah, 3, and then now if you divide this by 3, you get 6, and if you divide this by 3, you get 7. So it's 7 pi over 6. 7 pi over 6. Well, you can actually see this in the unit circle. So 210 degrees, right? So 210 degrees is around here. So this is 100 degrees, this is 210 degrees. 7 pi over 6. As you can see here. 210 degrees. So it's valid. Well, I think that's it for the video, and thank you.